For thousands of years, a reddish star has stood out from the constellation Orion, drawing the attention of anyone who looks toward the winter sky. Today, we know it as Betelgeuse, one of the most famous red supergiants in our galaxy. To the naked eye, it appears as a distinct orange-red point near Orion's shoulder. But behind that seemingly tiny light is a star so enormous that its scale is difficult to imagine. Betelgeuse is hundreds of light-years away. That means the light reaching our eyes today began its journey long before the modern world existed. When we observe this star, we are not seeing it exactly as it exists right now. We are seeing an image preserved by light and delivered across an immense stretch of space. Betelgeuse is also dramatically different from our Sun. Its surface is cooler, but its enormous size allows it to radiate an extraordinary amount of energy. If it occupied the position of our Sun, its outer atmosphere would extend far into the inner solar system, swallowing several planetary orbits. And unlike the Sun, which appears relatively stable on human timescales, Betelgeuse is constantly changing. Its surface is dominated by enormous convection cells. Hot material rises from deeper layers while cooler material sinks again, creating gigantic movements across the stellar surface. These structures can change the appearance and brightness of the star over time. Its outer atmosphere is equally turbulent. Betelgeuse continuously loses material through powerful stellar winds. Gas and dust escape from the star and expand into surrounding space, creating an enormous environment around it. This mass loss is an important part of the life of a massive star. Inside Betelgeuse, nuclear fusion has transformed lighter elements into heavier ones throughout its evolution. But massive stars eventually reach a stage where their internal fuel can no longer provide enough pressure to balance gravity. That is what makes Betelgeuse so fascinating. It is believed to be approaching the final stages of its stellar life. The star's brightness has varied repeatedly, and astronomers have watched these changes for generations. One of the most dramatic episodes occurred around 2019 and 2020, when Betelgeuse became noticeably dimmer. The event immediately attracted enormous scientific interest. Could the star be approaching its final explosion? The answer turned out to be more complicated. Observations suggested that a large amount of material had been expelled from the star. Dust formed within that material and temporarily blocked some of Betelgeuse's light from reaching Earth. In other words, the star itself had not suddenly switched off. Part of its enormous atmosphere had moved between the star and us. This event offered astronomers an extraordinary opportunity to study how a massive red supergiant behaves. It also demonstrated how difficult these stars can be to predict. Betelgeuse is not a smooth sphere of glowing gas. It is a turbulent environment where enormous amounts of material move through its atmosphere, while the star gradually approaches the final stages of its evolution. Eventually, when its core can no longer support itself against gravity, Betelgeuse is expected to undergo a catastrophic collapse. That event could produce a supernova powerful enough to briefly transform its appearance in Earth's sky. But when will it happen? That is the mystery. It could occur relatively soon on astronomical timescales, or the star could continue for much longer than human civilization has existed. And because Betelgeuse is hundreds of light-years away, there is another remarkable possibility. The event could already have happened, with the light still traveling toward Earth. For now, the red giant remains above Orion. Every night we see it, we are watching ancient light from a star approaching one of the most dramatic endings possible for a massive star. But its eventual explosion would not simply destroy something. It would begin another cosmic chapter. The eventual fate of Betelgeuse is written deep inside its core. Massive stars live fast compared with stars like our Sun. Their enormous gravitational weight creates extreme pressure and temperature, allowing nuclear reactions to occur at extraordinary rates. Over millions of years, fusion transforms lighter elements into progressively heavier ones. But there is a limit. When a massive star develops an iron-rich core, the situation changes dramatically. Unlike earlier fusion reactions, producing heavier elements from iron does not provide the energy required to support the star. The balance between gravity and internal pressure can then collapse. When that happens, the core can fall inward with astonishing speed. The outer layers respond to this violent change, producing a shock wave that can tear through the star. The result is a core collapse supernova. If Betelgeuse eventually reaches this stage, the explosion could become one of the most spectacular astronomical events visible from Earth. For a period of time, the star could become dramatically brighter than it normally appears. Its light could dominate the constellation Orion and potentially become visible during daylight under favorable conditions. But despite the dramatic appearance, Betelgeuse is far enough away that scientists do not expect such an explosion to pose a serious threat to Earth. Instead, it would provide astronomers with an extraordinary natural laboratory. A nearby supernova could allow researchers to study the death of a massive star in unprecedented detail. Telescopes across the world would immediately observe the event across multiple wavelengths, while detectors would search for particles released during the collapse. The explosion would also scatter material into space. Elements created inside the star would be released into the surrounding interstellar medium. Over enormous periods of time, that material could become part of future stars, planets, asteroids, and other cosmic structures. This is one of the most important lessons of stellar evolution. Stars do not simply appear and disappear. They recycle matter. The atoms produced inside ancient stars eventually become part of new generations of cosmic objects. Some of the elements found on Earth were forged inside earlier generations of stars that lived and died long before the Sun was born. Betelgeuse is therefore part of a much larger cycle. Its current stellar wind is already returning material to space. A future supernova would accelerate that process dramatically. But there is still no reliable countdown to its final explosion. Astronomers can study its size, temperature, brightness variations, atmospheric behavior, and evolutionary stage. Yet predicting the exact moment of collapse remains beyond our capabilities. That uncertainty makes Betelgeuse even more fascinating. Every observation provides another clue. A change in brightness may reveal something about its atmosphere. A new dust cloud can tell researchers about mass loss. Changes in its spectrum can reveal information about the material moving through its outer layers. The star is effectively telling its story through light. And because that light has traveled for centuries before reaching us, every observation is also a glimpse into the past. One day, the signal of its final explosion will reach Earth. Perhaps astronomers will witness it during our lifetime. Perhaps it will happen thousands of years from now. Or perhaps Betelgeuse has already collapsed, and the evidence is currently crossing the darkness between the star and our planet. We simply do not know. For now, the red giant continues shining beside Orion's familiar belt. It reminds us that the stars appearing permanent in the night sky are actually evolving worlds, changing on timescales far beyond ordinary human experience. Betelgeuse is enormous, unstable, and temporary. And when its final moment arrives, the explosion will not erase its legacy. It will scatter that legacy across the galaxy, providing raw material for whatever comes next. The giant may eventually die, but the elements it created could live on for billions of years.